lecture for you. Today we will study rest of the topics in electronic configuration in periodic table. Okay, so today we will see the electronic configuration of transition metals. So the first transition metal in periodic table is scandium, whose atomic number is 21. So its configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Okay, so as we can see that its configuration is too long, so to make it shorter, what we do is here you can see it can also be written as argon 4s2 3d1. Why we wrote argon here? Because for argon the atomic number is 18, so its configuration will be up to this. So this is the configuration for argon. So in short, we can replace this electronic configuration with the name of the element or the symbol of the element. So argon. So this is the configuration for argon having atomic number 18. So we wrote like this. Now rest of the part will be written like as it is. Okay. So here for copper, the atomic number is 29. So its configuration will be argon 4s1 3d10. Okay, or we can also write it as argon 4s2 3d9. Okay, means here the difference is here in 4s only one electron is there and rest of the electrons are in 3d. But here in valence shell 3d there are 9 electrons and 2 electrons in 4s. Okay. So we can write its configuration like this or this. So these are their respective arrangements according to their electronic configuration. So here we can see that in 4s, if we put only one electron, then in 3d all the electrons will be paired up. Okay, that means the 3d orbital will be fully filled if we put only one electron in 4s. But if we keep 2 electrons in 4s and rest of the electrons in 3d, then one of the electron from 3d will remain unpaired. That means it will not be completely filled. 3d here is not completely filled, but here 3d is completely filled, and here 3d is the outermost orbital. So when we compare these two, then among both of them, first one will be more stable as compared to second one, because here we can see that the outermost orbital is fully filled or completely filled. So it will be more stable as compared to the second one. So this is the correct configuration for copper. This is because for achieving the most stable configuration. Okay. Now similarly here for chromium, the atomic number is 24. Now we can write it as argon 4s1 3d5 or argon 4s2 3d4. Okay. Here also the same case is there, but here the 3d in first electronic configuration the 3d is exactly half filled and 4s is also exactly half filled. But here you can see that 4s is completely filled and 3d in 3d it is not exactly half filled. Actually one electron is missing here and that electron is present in 4s. So when we compare these two electronic configuration, again first one is the most stable configuration, as all the orbitals, both the second last orbital and the last orbital both are exactly half filled. So we know that if an orbital is exactly half filled or fully filled, then it is the most stable configuration. So first one will be the stable configuration for chromium. So for copper, this one is the configuration, stable configuration. So we will follow this configuration, and for chromium we will follow this configuration. Okay, instead of the second one, we will follow the first one. Okay. Well, there are three kind of elements present. First one is main group elements or representative elements. So these are the elements which are present in S block or P block. Okay, so those are alkali metals and alkaline earth metals which are present in S block, and then boron family, carbon family, nitrogen family also known as pinocogens, then chalcogen, oxygen family, and halogens, noble gases. These are from P block. Okay, so these are the elements comes in the category of main group element or representative element. So for them, the valence shell is either Ns or Np. As we can see in their general electronic configuration, for S block element it is Ns1 to 2, and for P block elements it is Ns2 Np1 to 6. So these are the general configuration, electronic configuration for these two blocks. So according to this, the valence orbital is Ns, I mean, yes, is S or P orbital. So valence orbital for main group element is either S or P orbital. Okay. Now the second type of element present in periodic table is transition elements, also known as transition metals, because all the elements present in this is metals. So they are also known as transition metals, and these are the elements which comes under D block. Okay. So for them the general electronic configuration is N-1D 1 to 10 and Ns 1 to 2. So here we can see the outermost orbitals are N-1D or Ns. So for them the valence shell will be N-1D or Ns. Okay. The third type of element present in periodic table is inner transition elements. So under this, lanthanides and actinide series comes under this elements. Okay. So the elements present in lanthanide series, for them the general electronic configuration is 4s1 to 14, 5d0 to 1, 6s2. And the elements which comes under actinide series, for them the general electronic configuration is 5t0 to 14, 6, I mean 5f0 to 14, 6d0 to 1 and 7s2. So from these two general electronic configurations, we can say that for them the valence shell or the valence orbital will be n-2f or n-1d or ns. So these three will be the valence orbital for inner transition elements. That's all for today. For more info, please subscribe our channel. Thank you.